Hello everyone, this is Charan from Sri Venkateswara College of Engineering. I am here to speak about the myths of software development. The world of software development is a rife with common myths and the misconceptions and the effortless maintenance. The humble beginners of software in 1940s and in 1940s, the earlier computers like UNI, VAC laid the foundations, and in 1950s, programming languages like Fortran and COBOL emerged. In 1960s, mainframe computers regulated business operations, and in 1970s, personal computers brought software to the message. And the software development starts humbly and with pointers building the first digital computers and programming languages by hand. As the technology advanced, the software becomes a intelligent part of business of everyday life. And the rise of the rockstar developer. In 1990s and 2000s, witnessed the emergence of the rockstar the developer, a skilled programmer with a outsized ego and cult-like following. These elite coders were celebrated for the technical powers and unconventional work styles, sparking a culture of hyper individualism in the industry. The myths of the 10th engineer, productivity myth and collaboration matters, Astalic approaches matters. In the production myths, the idea that some engineers are 10 times more productive than their peers is a myth. Productivity is a complex and depends on many factors behind just coding speed. Collaboration matters. Great software is built through effective collaboration, not individual heroics. Top engineers understand how to work well with others, not just write a code in illusion. Ashalik approaches. Software excellence requires a deep understanding of engineering principles, uh, like design partners and the best practices, not just their raw coding talent. The fallacy of a waterfall methodology. Linear approach and flexible frameworks, embracing complexity, like others. The waterfall model assumes software development is a linear sequential process. It really modern projects requires in interactive adaptability approach to address changing requirements and in flexible frameworks. Agile methodology like Scrum and Kanban enables terms to rapidly respond to feedback, incorporate new features, and deliver working software incrementally. And in the embracing complexity, the waterfall model fails to account for the inherent complex of software projects where bugs, technically depth and scope of sque and common requiring of interactions. The illusion of future complete software. Endless iterations, changing requirements, technical debate, and emergent behavior. In endless iterations, software is never truly future complete. There is always room for improvements, optimization, and new capabilities. Adopting an interactive development process is a key to stay ahead of evolving users' needs and in changing requirements. Users' expectations and business requirements can shift rapidly, making the notion of complete software product unrealistic. Agile methodology enables terms to adapt to change and deliver incremental improvements. And the technical debate. As software grows in complexity, technically debate accumulates. Dressing technology debate through regular refactoring and upgrades is essential to maintaining a healthy code base. And the emergent behavior. Software system often exhibits unexpected emergent behaviors that can't be predicted or planned for an interactive approaches allows terms to identify and address these issues as they arise. The myths of plug and play integration. The idea that software system can be easily integrated out of the box is the common myth. In reality, seamless integrations requires careful planning, custom configurations, and extensive testing to overcome capabilities issues and data synchronization challenges. Successful software integration depends a deep understanding of APIs, data formats, and legacy systems. It's an ongoing process, not a one-time event, requiring continuous maintenance and updates as technology evolves. The fallacy of infinite scalability, limits of hardware, architectural constraints, cost of scaling, evolving requirements. In limits of hardware, physical hardware resources like CPU, memory, and storage have infinite capacities. Scaling software to run on ever large servers as practical limitations. In architectural constraints, software architectures are designed for specific use cases and traffic volumes. Scaling behind their intended scope can introduce performance bottlenecks and architectural complexity and evolving requirements. As software grows, new features and functionalities are added, increasing complexity and making it scalability an exclusive goal. Cost of scaling. Scaling software linearly with users growth becomes prohibitively expensive. Optimizing for efficiency and leveraging cloud-based scaling are often more cost-effective. The myth of effortless maintenance. The software requires constant care and upkeeping, security patches, bug fixes, features improvements. These tasks are ongoing responsibility, not a one-time event. Neglecting software maintenance leads to unvariabilities, performance issues, and inability to adapt to changing users' needs, and some other things. Embracing the realities of software. Software development is a complex, ever evolving field that requires a pragmatic approach. By understanding the myths and challenges, we can build more resilient, adaptable systems that serve our user needs. Thank you.